The array works just like the vector and the matrix, but it can have any number of dimensions, so it's n-dimensional. But just like the vector and the matrix, it can only contain one type of data, numeric, character, logic, or complex. And in this example, we make an array x, and the first argument to the command array is the data, just like in the matrix. It's in this case, it's the numbers 1 to 24, which we want to store in the array. And then you have to tell R how many dimensions there are to be and how many rows, columns, and so forth. And you can't give this in separate arguments because R does not know how many dimensions there will be. So you give them all in one argument as a vector. You create the vector by combining the numbers, in this case 3, 4, and 2. The interpretation of this is that there should be 3 rows, 4 columns, and 2 layers, so to say, the third dimension, the Z axis. Of course, you could have a 4-dimensional array as well, and then you would have a comma and something else here. You couldn't visualize that, but it would be perfectly useful. And if we look at x, what we have, you get this from R, comma, 1, which tells you all the rows, all the columns, the first layer. And then R presents a matrix, which represents the first layer. And as you can see, it has been filled the common way, 1 row at a time in the first column and then the second column. So you have the numbers 1 to 12 here, with 3 rows and 4 columns. And then comes comma, 2. All rows, all columns, second layer. And then another matrix representing the second layer with the numbers 13 to 24. So it starts in the first layer and then goes on to the second layer. If you want to subscript and get a particular value out of the array, you write, for example, like this, x brackets around 1, 3, 2. And this indicates you are interested in the first row, the third column, the second layer, and you get in return number 19, because this is where number 19 is. It's the second layer, as you can see, it's the first row and the third column.